For our third Biz Stats video, we're going to think about a particular type of data that you'll encounter quite frequently, and that's what we refer to as categorical data. If I can just take you briefly to a spreadsheet example here. If you look at this data, which you would have seen in video number 2, let's take wages. This is what's referred to as numerical data because it's actually numbers that tell us how much income a person earns. But in contrast with that, if we come across here to occupation, occupation is a categorical variable. It's a category that people are placed in. Either they are managers, clerical workers, or labourers or other types of workers. So that's one example. Gender is another categorical variable here. People are put into 2 categories, and so is labour force status. So that's what we mean when we're talking about categorical data. The statistical idea of categorical data comes from some distributions that you may have heard of before, and one of those is the binomial distribution. The binomial distribution applies in particular when there's only 2 categories. So in the example we just saw there, people have been classified as either male or female, so there's only 2 categories there, or one of the other columns, people were either employed or not employed, unemployed. So there's 2 categories of responses, or yes or no in this particular example that's here. So the binomial distribution is a probability distribution that tells you if you have a certain number of people, what proportion of those people would be in the yes category versus the no category, employed versus unemployed, or whatever it might be. And then in how X might represent the number of people in that category. So we're not going to go into the statistical distribution here in any great detail, but just to alert you to the fact that you'll see the binomial distribution in these situations where there's these 2 possible outcomes. The 2 possible outcomes is found in the name of the binomial distribution, the bi part of the BI, standing for sort of bi, two values that it could take. So in this situation where we've got potentially, say, 50 people, and they're either yes or no, depending on whether they actually had problems with their mortgage. You might find a different possible number of people that would actually respond a certain way. So suppose, for example, across the whole population, 40% of people said yes to this question, whatever the question was. If you took 50 people, then on average you're going to get 20 out of those 50. So 40% of the 50 would represent about 20 people saying yes to the question. But if you took another 50, it won't be exactly 20 necessarily. It might be, but it might be 21 or 22 or even 25 up to 30 or down as few as 10. So this is the kind of values you could get in a group of 20 people answering how many of those answer yes to a particular question. If the overall proportion is 40%. If, on the other hand, the overall proportion is 5% of 40 people is just an average of 2 people. And so the most common value you might get in a sample of 50 might be 2 people saying yes to this question. But you might get none, or 1, or up to 5, 6, 7, or 8 people. So there's a number of possible answers, but they're going to be clustered around the overall proportion, which is 5%. Okay, so that's the binomial distribution. That's the statistical theory around it, and if you do any more study in statistics, you'll get into that kind of stuff in a bit more detail, and it's really where a lot of the underlying ideas come from for the data we look at. We're now going to spend the rest of this video just thinking a bit more specifically about the data and how we describe it and how we represent it. So mostly here we're talking about sort of the visual representation of data. But before we do that, one more distribution to think about is sometimes you've got multiple categories. If we just go back to our spreadsheet again, in the case of occupation, we have at least 3 occupations here: manager, clerical, labourer, and then we've got blank as well. So, and there are possibly others. So sometimes you have a situation where there's more than 2 possible categories, and then we're in the world of what's called the multinomial distribution. Multi for many, more than 2. Here's another example here, what employment category of people. So in that case, we've got the same idea. We've got a probability of being in each of in the categories, but this time instead of just being, 50% chance being male, 50% chance being female, you might have a probability of being employed and another probability of being unemployed and part-time and then unemployed and so on. So that kind of becomes a more complicated probability table, and one that, again, will be reflected in potentially in a set of data that you've got. Okay, now on to the practicalities. What do you do with data like this? How do you represent it? If you've got a bunch of data and you want to work out how to present it to people, because a lot of your task, as we emphasised before, a lot of the task of the data analytics person is working out how to communicate ideas with the statistics that you've got, with the data you have. And one way you do that with this kind of data is by putting together some tables or perhaps some visual charts that capture the message. So we'll think mostly about tables here with one or two digressions into charts. So here you've got an example. 5,000 people, and we know something about their main medical condition. What's the biggest primary medical kind of problem they've got? It could be asthma, cancer, depression, diabetes, or none of the above. These are chronic diseases that are commonly occurring in society. We also know something else about these people, which is how much exercise they have, and they either have not much or a reasonable amount of exercise. Okay, so this data is actually generated from a multinomial distribution, and so we're going to work out how we might present that data to people. So if we just concentrate, first of all, on just one of the characteristics of interest, which is what kind of medical condition do people have, you might put together a little table here. This is what's known as a frequency distribution. All the different categories and how many people fall into that category. You'll see in your tutorial work how you produce a table like this using Excel and constructing what's called a pivot table. So this is the output here. This tells us how many people are in each category. It's interesting enough. You can see the most common category is none of the above. So well over half the people don't have any of these diseases, but the most common of those that do exist is depression with 493, and then the least common is diabetes with a couple of hundred. Okay, so you get some kind of messages from presenting the data this way. It's actually probably not a bad thing though to present the data with kind of visually with what we refer to as a bar chart. Okay, so this is kind of interesting, and you get a little bit easier for you to see which of the bars which are taller and which ones are shorter. It's actually a bit of a pain, this bar chart, because none of the above is such a big category that the others are really not much different. So if I was doing this bar chart, I'd probably get rid of that category, and I'd say just let's look at the people who have a chronic medical condition, and then these bars would become a bit taller and be much more obvious that depression is the most common and diabetes is the least common and so on. So it's probably not a great example of how we should be doing it, but you get the idea. But you know, there's a problem with this kind of chart here, because these numbers are interesting, but often ideas get better conveyed with percentages. So let's present the same information in percentage form. You can see it's even more kind of useful in terms of being able to explain things in common terms. Nearly 10% of the population have depression, for example, as their primary medical condition. About 4% have diabetes as their primary medical condition. So you're starting to get an even easier. 64% have none of the above, okay, which means 35 or so percent have at least one of these. Okay, so you're getting some nice sort of ways of explaining things in words that people can relate to. So I recommend going for percentages in many cases. Or you might want to represent it in a bar chart, which is just another way of showing how this thing's distributed. And again, this is, a pie chart. This is not a great example because it's dominated by the none of the above category. So if we imagine this pie chart without that category, we'd be able to see quite clearly which are the bigger slices of the pie and which are the smaller slices of the pie. But it's there as an option, sometimes a good way to communicate things. Okay, that's all fine. That's when we're just looking at one of the dimensions, which was medical conditions. But, you know, that's not particularly interesting, because one of the beauties of data analytics is trying to find patterns in data, trying to find kind of connections between what's going on here and what's going on over there. We want to know, why is it that some people have a lot of depression and other people have a lot of asthma and so on. And so we need to be able to sort of get some idea about how all that works together. But I'm just going to pause because my daughter's got home and she's going to come charging in and try and interrupt your interesting video. Okay, we're back. My daughter's home. She's made her noise. She's off having her dinner now. Let's get back to what we were talking about. So far, we were just thinking about one characteristic, which was what primary medical condition people have. But it's great if we can look at the connection between that characteristics and some other characteristics of people and see if we can spot patterns in data. That's when data analytics becomes interesting, because you can start to see what's making the world work. Why is it that some people are more likely to have heart disease or depression or asthma and so on? So we're going to concentrate on exercise. Exercise is seen as one of the absolute keys to prevention of chronic diseases. And so just trying to, in simple terms with a simple set of data, trying to see if there's any pattern of how much exercise people get and the kind of illnesses that they suffer from. So we've got the data now presented in a two-way table. Type of illness on the rows and level of exercise on the columns. You'll see there's a third column here, which is a pretty annoying one, which is blank. Some people didn't answer the question. We've actually got rid of those people, so the blank column is just blank. So it's there. So before I put this nice little thing into a report, I'd want to tidy that kind of thing up. But that's as it comes out of Excel when I do what's called a pivot table. Okay, so that tells us something interesting. You'll see here that in terms of exercise, most people engage in a minimal amount of exercise, but there's a reasonable number, about 3,200 out of the 5,000, and there's split between all the different types of illnesses. So people with asthma, most of them engage in minimal exercise, but there is a reasonable number who have moderate exercise. Heart disease, look at that, that's interesting. 220 minimal exercise, 43 moderate exercise. So look, not many people with heart disease engage in moderate exercise. So maybe there's a bit of a clue here that, if you don't exercise much, you're more likely to suffer from a heart disease. Maybe that's a clue about that. So you sort of get a bit of an idea of some of these patterns, but again, it's a little bit hard to identify just how things work when you're just looking at the data in this way. There's possibly better ways for us to actually do it. So one way we can sort of get that information across a little bit better than simply putting in tables of numbers here is by working things out in percentage terms. And once again, these annoying blanks just make this look like a rather ugly table, so we'd want to get rid of those before we presented this in any meaningful way, but we can still learn something from the other columns. Let's look at the people who have heart disease, for example. So of the people who have heart disease, 83% of them, nearly 84% of them, don't engage in much exercise. 16% have moderate exercise. Okay, so as observed on the previous page, it looks like not, the connection between exercise and heart disease is that if you have heart disease, you don't exercise much. Perhaps contrast that with asthma. There's a much higher percentage of people with asthma who do engage in a reasonable amount of exercise, nearly 40% versus 16%. So you can get a clearer message here about the role of exercise and its connection to these illnesses, particularly chronic diseases. We wouldn't be necessarily brave enough to say that there's a causal relationship from one to the other, but there may be. So it could be that if you engage in, for example, if you engage in moderate exercise, then you're going to be much less likely to have heart disease than if you're a bit of a non-exercise type, for example. Okay, so there's a bit of a clue here about possible links between exercise and disease, and it's much more easy for you to see those links when you start to present things in this variation here, which is called a percentage of row table. Percentage of row can be thought a little bit like sort of just isolating out this particular category of people. So this row tells us, just consider the people who have asthma. What's the breakdown of their exercise composition? And you see 60% or so don't exercise much, nearly 40% do exercise. Let's take the people with diabetes. 72% don't exercise much, 28% do exercise a reasonable amount. Okay, so you're thinking about, given this, what's the chances of people exercising or not exercising? We could, if we wanted to, have done the table this way. And this is what's referred to as percentage of column. Same information, but now instead of the rows adding up to 100%, the columns add up to 100%. So, of all the people that engage in minimal exercise, you can see here that 62% of them don't have any of the illnesses, 10% have depression, 8% have asthma as their primary illness, and so on. Of all the people that engage in moderate exercise, 9% of them have depression, and only 2%, for example, have heart disease. So this is again another clue that suggests to us that if you're a good exerciser, there's a pretty small chance that you'll have heart disease. So there's a clue that maybe exercise is a good way of reducing the incidence of heart disease. So you can see here what we started out doing was just thinking for these categorical data which can be put into just a few categories, 2 or more categories. We first of all just want to describe what's going on, but already once we start looking at 2 particular characteristics at the same time in this sort of two-way table, we start to get a message coming through about possible links between these different variables, which obviously we'd want to explore a bit more thoroughly before we draw any conclusions, but we're starting to see some interesting insight into the way in which one factor or one characteristic interplays with another. And that's one of the beauties of data analytics, is to see those kinds of patterns and then to start to dig further into them. Okay, thanks for that. That's all for that topic.